Hey there, my pre-Calc people. I gotta turn on my Mobi first. Rough start. Alright, today what are we gonna look at? We are looking at end behavior. Alright. Y'all can read, but end behavior is how the function acts when it gets really big, like goes to infinity, and gets really small, goes to negative infinity. Alright, so what we are going to do to look at our limits and look at end behavior is we're gonna look at two different things. First thing is our degree can determine our end behavior. And we're going to look at whether or not the function is even or odd. We're really just going to look at the biggest x, and that'll help us give us end behavior. And then we're also going to look at our leading coefficient. Mostly, is it positive or negative? Okay. Let's get to it. First things first. So let's look at this beast. We have, this is an odd function, correct? Well, it's not that weird, Mr. Twilliger. It's odd enough. Goes up, comes down, goes up to infinity, goes down to negative infinity. What would my coefficient sign be of this? Positive. This is a positive odd function. Positive odds start down and then they go up. Okay? So for this one, my limit as x approaches infinity, as I go off to the right, is infinity. It goes up. And my limit as x approaches negative infinity, goes to the left, is negative infinity. Whereas this odd function over here has a negative coefficient sign. So now as I go to the left, my function goes up to infinity. And as I go to the right, it goes down to negative infinity. Okay? Now what about evens, you may be asking? Well, that's a good question. This is a positive even. And now what do we notice? They both go up. They both go to positive infinity. Oops. Whereas when I have a negative even, they both go down to negative infinity. Okay? Anything too scary so far? Good. So, let's consider the domain and range for each degree family. As x goes to infinity and x goes to negative infinity, what do I notice about the f of x or the y values? Okay. Well, for evens, both are the same. Right? If one went to infinity, the other went to infinity. And vice versa. For odds, they were opposite. So if one was infinity, the other one was negative infinity. Okay. And how does the leading value matter? Well, if our leading coefficient was less than 0, it flipped the end behaviors. Okay. Okay. Let's look at some examples. Use the calculator, sketch a graph, and then we're going to figure out some stuff about the graph. So here's our first one. So let's sketch it down here. That's what it looks like. Now, what is my n? What is my highest power? Well, it's 3. So it's going to be odd. Now, what's my leading coefficient? That's a of m. Now, for this one, it's -1. So negative. So this is going to be a negative odd. Does it look like a negative odd? Yup. So now what's my limit going to be as x goes to negative infinity? So as I go to the left, well, it goes up to positive infinity. And what about as x goes to positive infinity to the right? It goes down. It goes down to negative infinity. How many turning points do I have? I have 1, where it goes from decreasing to increasing. 2. 2 turning points. A fork stuck in the road. All right. Let's look at the next beast. The next one I graph it looks like kind of like this. I'm just kind of winging it. All right, now for this one, my n is 4, so even. My leading coefficient is 1, positive. Now, my limit as I approach negative infinity, I'm going up, so it's positive infinity. My limit as I go to positive infinity, well, is positive infinity. This one I have 1, 2, 3 turning points where I change direction. Okay. Okay. Now notice this, the graph has at most n-1 turning points. So if my degree is 6, I'll have at most 5 turning points. If it's 100 degree, I'll have 99 at most turning points. And I'll have at most n zeros. I could have less, because remember those complex solutions can play a role into it. But I can't have 7 solutions if it's x to the 6th power. All right, I hope that gives you guys a start. Enjoy.